If I create a video because of your comment, I'll give you a shout out. So be sure to let me know in the comments what you'd like to see. Today I'll be going over how to hook up and program a TB67H420FTG motor driver. That's this chip right here. This is on a carrier board. So what I want to do first is I just want to go over the pin assignments. So we have this first pin here, which is VM. This is your motor voltage. So whatever your voltage is in for your motor, you can access that voltage here after it goes through the protection circuits. Then we have a ground pin. This ground pin is tied to the rest of the grounds. However, I tried grounding the board with just this ground pin and it didn't complete my circuit for whatever reason. So I actually had to tie in the ground over here. So just know that in case you have some problems and you're not getting your voltage into your motor driver board. Okay, the next pin we have is a VCC. This is a 5-volt out. It is mentioned on the documentation that this only supplies a few milliamps, so it should only be used to power circuits, like logic circuits, nothing with any significant amount of current. Okay, then next we have our in A1 pin and our in A2 pin. These two pins together are going to control the direction of our motor. The next pin we have is the PWM A pin, and this pin is going to control the speed of motor A. Then we have our in B1 and in B2. This is going to be the same thing. It's going to control the direction of motor B. And then our PWM B, which is going to control the speed of motor B. Following that, we have the LO1. This is a normally high 5-volt signal. And when it's pulled low, it means you either have an overcurrent or an overtemperature fault. Then we have the LO2, which is normally high. It's a 5-volt signal, and it will be pulled low when there's an overtemperature or an open load fault. So I would assume that since there's 3 states and there's only 2 pins, you would check for an overtemperature by checking both of these pins. If they're both low, then you likely have an overtemperature. If either one is low by itself, then you have in the first case here, you have the overcurrent, and then in the second case, you have the open load fault. Okay, so then we have this pin on the corner here. This is the VREF A, and then around the corner we have a VREF B. Both of these pins are for current chopping. Okay, the VREF A is for current chopping on motor A, and then this one is for motor chopping on motor B. Okay, it's defaulted to 3.6 volts. The formula for this is the voltage times 1.25 when you're running 2 motors. So 3.6 times 1.25 is 4.5. That means each motor gets 4.5 amps, and at that point, if it exceeds 4.5 amps, you'll get an overcurrent fault and the board will shut down. Now in single motor mode, because this can support 1 motor, the multiplication is, or the formula is VREF, which is 3.6 volts by default, times 2.5. So that means that you can support 9 amps of current with a single motor. Now you can lower that voltage so that you can adjust the current chopping limit. Say you only want it to chop off, 1.25 current. Then you'd have a voltage of 1 supplied to either one of these pins for a dual motor setup. Okay, over here we have these 4 pins here. These first 2 at the top, closest to the inside of the board, are your VCC. These again are the 5-volt signal with only a few milliamps of current supplied. Okay, then we have, over here we have the TBLKAB pin, which is the blanking time configuration input pin. It says to see the data sheet for this. I wouldn't worry about using this pin. This other pin here that's closest to this side of the board is the HB mode. This is going to define whether or not you have a single motor mode or a dual motor mode. If it's high, then you are going to have single channel mode, which is going to support 1 motor. If the voltage is pulled low to 0 or ground, then you're going to support dual channel. By default, this is pulled low, so you have a dual channel by default. And it should also be noted that these 2 pins should not be changed while the board is on. It should be changed when the board is off. If you want to pull this high, then you would just use something like a 10K resistor and then solder it to here and then have it pulled to voltage to your 5-volt signal. On the other side of the board, we have our voltage input, which is our motor voltage input. We have the positive and then the ground. And again, this ground is the ground that I tied to my rail ground. And then we have motor B positive, motor B negative. So this is where you'd hook up your wires that go to your motors. And then we have motor A negative and motor A positive. Now if you'll notice, I do have a positive wire going into motor A negative and a negative wire going into motor A positive. That is because if we were programming these motors, and say we on in A1 and in A2 we put high and then low, this is going to cause it to, say, for example, go clockwise. Okay, and then this one will also go clockwise, which is great if they're both facing the same direction. However, when I build my line following robot, I have it like this. So this one is flowing clockwise with high and then low, so that's going to drive forward. If this one is going clockwise, then that's with the high and low, it's going to go backwards. So the easiest way to solve this problem is just to flip these two wires so that the one motor goes backwards when high and low is applied, and the other motor goes the normal direction when high and low is applied. That way, when they're both facing different directions, they both go the same direction when high, low, or low, high is applied. In my example circuit, I'm using a Teensy to control my motor driver, which is going to control my motors. You could use an Arduino Nano or an Arduino Uno if you'd like. You just have to note that, again, in A1 and in A2 need to be digital pins, and PWM-A needs to be a PWM pin. And then in B1 and in B2 and PWM-B need to be digital and then PWM pin. Okay, so I have that hooked up here. I have A1, A2, B1, B2, and then these two are my digital pins. So PWM are these are my PWM pins. I have PWM for motor A, PWM for motor B. Okay, at this point I would like to go over how to program the motor driver. So I'm going to start by just writing a simple program. My motor pins were 5, 6, 7, 8, 9, and 10, where 5 and 6 were the digital for pin A, 7, 8 were the digital for pin B, and then PWM-A and PWM-B were pins 9 and 10. So I'll start by writing out what these were so that it makes it a little more easy to understand. First thing we need to do in any program when we're using pins is to define the pin modes for those. Alright, let's just make it a little easier, a little faster. Okay, and then again, to control our motor, you drive one of the digital pins high, one of the digital pins low, and then provide a PWM output for our speed. So let's say we want to drive motor A. Then we would say digital right, motor A1, high. We'll do the same Only we'll change this to motor A pin 2 to low. And then we will provide a PWM, which is an analog write to a PWM pin. And we'll do just half speed. So the values go from 0 to 255. We'll use 127, which is about half speed. And then we will pause for 1 second. And we'll repeat the process for motor B. Only afterward we will turn motor A off by sending it an analog write of 0. And we'll do the same for motor B. Okay, so by reading this code, we enable all of our pins. We drive motor A at half speed for 1 second, turn it off. Then we drive motor B at half speed for 1 second, and then turn it off. At this point, I would select my board by going to Tools, Board. However, it appears I don't have Teensy Duino installed, so I'll use this as an opportune time to show you how to install the Arduino or the Teensy Duino application. So I'll just search for Teensy Duino. It's the first one here. Okay, and I have a Mac, so I'll just download that. Alright, so as it says, to add Teensy support to your Arduino software, just run this installer. Now just a note, we have to close Arduino first. So make sure that's closed. Double click this. Are you sure you want to open? Yes. Alright, next. At this point I need to find my Arduino app, which is right here. On Windows you would just simply go to C, Programs, Arduino, and then select that folder. As soon as this next button enables, then you know you've picked the right spot. So go to next. I don't want any of these added libraries. This is helpful if you have, if you're not used to Arduino and you want to try out some new things, this can automatically install a whole bunch of libraries for you. So I'll go ahead and click install. And it should be done. So now I can close this. If I open up Arduino, I should have my Teensy boards available in the boards menu now. Open this up. Boards. Yep. So there we go. Teensy 3.2. That's actually what I'm using, so I'll just keep that the way it is. My Teensy is plugged in right now, so I'll go to ports. This is the correct port. As you can see, it says Teensy. I'll open up my example that I just had. Alright, and let's try uploading this, see what happens. One important thing I do want to mention is that it's important not to plug in your battery power and your USB power at the same time. There is a chance that your voltages could get crossed and you could fry your computer itself. With Macs, this isn't so much of an issue, although I would still recommend you don't actually do it, just to be on the safe side. I do know of at least 2 cases where someone has completely fried their motherboard by plugging in the USB while the battery was still connected. Okay, I will select upload. It should open up to Teensy. It reboot automatically. Okay, and now you can see my motors aren't moving. That's simply because I don't have my battery hooked up. So there's not enough power. There's actually no motor power supplied to my motors right now. Okay, I'll plug this in and we'll see what happens. Now, the way we programmed this, we have, again, motor A driving for 1 second first. So motor A is going to be this motor. So this motor here. And then this one is going to be driving. Now we drove them both in the same direction, and because one of my motors is hooked up in reverse polarity, then they're both actually going to go the same direction. So if they're both reverse, they'll both go in reverse. If they're both going forward, then they'll both go forward. Let's see what it does. Okay, that went forward, and that went forward as well. All right, so success. Now at this point what I would do is I would copy this code here for driving the motor A and driving the motor B, and I would put them in their own functions to create functions. That way we don't have to copy these 3 commands every single time we want to adjust the motor direction and speed. So I would create a function telling it which direction to go, or just supplying a motor speed with a positive or negative and then deciding which direction to go based on the value of the motor speed. However, I have created a library which you can find here at github.com/mcc-robotics/dynamic motor driver with underscores between each word. And what this motor driver library does is it allows you to use various different motor drivers. So I have support for the DRV8835, L298, the 754410, this TB67H420 FTG, as well as I think a few others. And you can see that I have 2 examples here. But what you would do is, if you don't know how to add this to your Arduino library, is you download the zip, and then you'd come over to your Arduino program. You'd go to include library, add a zip library, and then you would navigate to wherever that library is, and it would add it for you. Okay, I have already added it to my Arduino IDE. So what I can do is go to examples. I'll scroll down here, dynamic motor driver. Here's my example for TB67H420 FTG. This is a basic example. Okay, I've included some comments here showing you how to hook up your circuit. Now these pins are different, but if you were to hook up with these pins, then this example would work right out of the box. You wouldn't have to do anything. However, my pins are not those pins. So remember, mine are 5, 6, 9 for motor A, and then 7, 8, 10 for motor B. So what I'll do is I'll change this to 5, 6, 9, 7, 8, and 10. So we have digital motor A in, and then motor A PWM, and then we have motor B in and motor B PWM. Okay, after you've created your motor driver object, the only thing you have to do is call init. Now what this is going to do is it's going to do all those pin mode functions for you. So you don't need to actually set up the pins. You just call driver.init and it will set up all the pins for you. Now this one, it says let's move the left motor a bit. So this is just assuming that motor A is the left motor. In our case, motor A is the right motor. So motor B, so let's just flip this just in case. All right, so now we have this set up the same way. So motor A is our left motor, motor B is our right motor. Okay, so it says move our left motor forward a bit. Now this is also assuming that you have it hooked up in a certain polarity, so this may actually go backwards. And then let's move the right motor forward a bit, and then let's control both motors to drive straight. And what this does is it waits 1,000 milliseconds or 1 second after each operation. So let's go ahead and upload this and see what happens. Oh, I gotta plug in my board here. Okay, let's try that again. says done uploading. I don't like not seeing this flash, so I'll go ahead and hit that button so it re-uploads. And now let's see what happens. Either these are going to go, it's going to go, let's see, what do we say, left motor. So it's going to go forward, forward, and then forward. Or if we have it hooked up backwards, it's going to go backward, backward, both backward. All right, so backward, backward, and then they both went backward. Okay, so what we can do is we can change our pins. So change 6 to 5, 6 and 5. And then we'll change pins 7 and 8. So now we just swap those two. So now when we upload this, they should both go forward. And let's try it out. Oop, we gotta plug in my board again here. Alright, it says uploading, and it looks like it's going to crap out on me. Oh, no, it did. Okay, sometimes with Mac there's a bug. Sometimes Teensy has to be the active window before it will actually work. Otherwise, it will time out and say it couldn't upload. If it says it couldn't upload, all you have to do is make the Teensy active and then push this button. It'll re-upload the program. Because the way the Teensy works is Arduino will build the program and then put the file in a location. The Teensy application monitors that location, and when it sees that a new file is built, it triggers the upload. So even if it didn't actually trigger the upload, the file is still there. So by firing an upload by hitting this button, it'd be doing the same thing. So now these should both go, we should go forward, forward, and then both forward at the same time. So that's forward, forward, and then both forward at the same time. So that's perfect. And so the benefit with this library is it's pretty straightforward. You just set the motor A power to 50%. Set motor A brake. Now that means that you want to brake the motor. That stops the motor. There is a set motor A coast, which allows the motor to coast. So if you have a robot that's kind of heavy, you can coast and have it just coast to a stop, or you can brake, which locks the motor so that it stops completely. Okay, there are other functions as well. So there's a set motors functions, which you can set both motors at the same time. But not only does it make it easier this way, if you ever do change your motor driver, so say I wanted to change over to a DRV8835, which takes 2 pins for each motor, or an L298, which takes 2 pins for each motor, I would just change this object here to an L298. Now you can see it's orange because it recognized it. And I would just assign the pins that are for my motors. So if my motors were a 5, 6, 7, and 8, this would be the 2 pins for motor A, the 2 pins for motor B. Now all of this code will work exactly the same as it did for my other motor driver. So this is great. So again, if I have a DRV8835, again, that takes 2 pins, 2 PWM pins for each motor. Assuming this is 5 and 6 and 7 and 8, then all of my other code remains the same. The only thing I ever have to change with this library is tell it which motor driver I'm using and assign it the right pins. So as an example, if we open up the other example that I had here, Dynamic Motor Driver DRV8835 Basic, you can see the only difference is I adjusted the comments here. It tells you to use 4 PWM pins. And the only difference between the other code that we saw and this code is this single line of code. So I would recommend that you understand how the motors work by driving them manually or creating your own functions. When you get comfortable, go ahead and use the library. I like to have people understand how the program works and how to do it before actually using the library. Because if the library doesn't work, then you don't really know how to troubleshoot it. If you understand how the library works, or at least how a motor driving works, then you can understand why the motor library might not work. Hey everyone, thanks for watching. If you like this video and you want to see more like it, give me a thumbs up. And don't forget to subscribe.